Okay, in this podcast we're going to talk about concentration of solutions. Now we can talk qualitatively about solutions. We can say we have a dilute solution or a concentrated solution. And a dilute would suggest that we have just a little bit of solute in whatever solvent it is dissolved in. Or we could say we have a concentrated solution, which means we have a lot of solute in there. But they're not very specific. We can get quantitative, though. We can put numbers on the concentration using what's known as molarity and molality. Now, this is kind of done, of course, to make it confusing, but the terms are very similar. Molarity has a T, molality has molarity has an R, molality has a T. Molarity is a big M, molality is a small m, so you have to be very clear about what you're writing or what you're reading. Okay, so they're similar but different, so we have to be able to determine concentration both ways. So let's take a look at our problem. And we're going to focus on molarity in this podcast and molality in another podcast. So the term molarity, if you see a big M behind a number, it means the moles of solute per liters of solution. So if you see something labeled like this, 2 molar sodium hydroxide, and this is something you'd likely to see at a lab bench, right? What that says is I have 2.0 moles of sodium hydroxide that is dissolved in water to make 1 liter of solution. I don't add a liter of solution, a liter of water, but in total I have 1 liter of solution. And if I put an AQ here, then of course that means it's an aqueous solution. And generally, almost all our solutions are aqueous, and a lot of times we get a little lazy and don't put the aqueous there. Okay, so what is the molarity of a solution in which 88 grams of sodium chloride are dissolved in 0.75 liters of solution? Okay, so here we have 88 grams of sodium chloride. We know how much solution we're making. So again, molarity is moles of solute over liters of solution. We know the liters of solution is 0.75, so we're just going to put that in. But we've got to figure out how many moles of solute we have. So we can take that 88 grams of sodium chloride and find how many moles it is using its molar mass. And we get 1.5056 moles. Now that's a lot of sig figs, and I purposely carry extra sig figs, and I don't round to the number that I need until the very last step. Okay, so I'm going to go ahead and put that in the numerator. I'm carrying extra sig figs. I put that into the numerator and divide, and what I get is 2.01 moles per liter. And moles per liter is the same thing as molar, okay? So I would call this a 2.01 molar NaCl solution. All right, let's try another. All right, what is the molarity of a solution in which 10 grams of silver nitrate is dissolved in 500 milliliters? So why don't you go ahead and try to solve this, and then after you answer, see if you got it right. Okay, so again, molarity is moles over liters. I can take that 10 grams of silver nitrate and figure out how many moles that is. And when I do that, I get that I have 0.05887 moles of silver nitrate. So my molarity is my moles over my liter. I have my moles, my liters are 0.5. Now that's something you should be able to do in your head at this point. 500 milliliters is a half a liter, right? Because there's 1,000 milliliters in a liter. Okay. So I get 0.118 moles per liter, which is the same thing as saying 0.118 molar of silver nitrate. Okay. Let's do one more. How many grams of sodium hydroxide are needed to make 1.25 liters of a 0.400 molar solution? Now you could do these problems completely with Stoic, because if I have a 0.4 molar solution, what that tells me is I have 0.4 moles of solute over 1 liter of solution. So I can also use it as an equality and use it as a factor in my Stoic. So the given here is I'm trying to make 1.25 liters. So that's what I'm going to start with, 1.25 liters. And what I know is 1 liter is 0.4 moles of sodium hydroxide. And I know that 1 mole of sodium hydroxide is 40 grams of sodium hydroxide. And if I cancel things out, liters and moles of sodium hydroxide, I get 20 grams of sodium hydroxide. Okay, so you can do it all in one step when you're trying to figure out grams or liters. Okay, so here we go again. To what volume should 10 grams of sodium nitrate be diluted to make 0.47 molar solution? Okay, so again, this 0.47 molar is 0.47 moles per liters. I want to make 10 grams, so I'm going to start with that 10 grams. 10 grams of sodium nitrate, and I know there's 53 grams of sodium nitrate in 1 mole of sodium nitrate, and I know that there are 0.47 moles of sodium nitrate in 1 liter of solution. So here I cancel out things, and I end up with 0.40 liters. Okay, and that's going to do it.